Assalamualaikum. Okay, how are you, student? Hopefully you are doing great at home. Okay, so we are already in week 9. So week 9, okay, we are quite free compared to other week, okay, our other previous week. So for this week 9, okay, we will have no quiz at all. But you have to do your assignment. It is a group assignment, so means that you have to submit your assignment in a group. This means that one group for one assignment, not individually. All right. Okay, so we go back to our lecture. Okay, for this week 9, we are going to learn 3.3 subtopic in chapter 3, maximum and minimum point. Okay, so let's see what is a maximum and minimum point. Okay, so let's see the applications of differentiation first. Okay, so do you know what is this? This is a roller coaster, right? So have you ever ride roller coaster? Okay. All right. So what is the relation between roller coaster and maximum and minimum point that we are going to learn? Okay. So the roller coaster is actually the one of the applications of maximum and minimum point. Okay, so can you see here? Okay, so this is known as the highest point, or also known as a maximum point. Okay, and can you see here? Here is a lowest point and also known as a minimum point. Okay, so that is the applications of differentiations in of our daily life. Okay, so there are many applications of differentiations in our daily life. Okay, so let's see. Okay, increasing or decreasing. Okay. All right, so in maximum and minimum point, we will consider, mostly quadratic. Okay, mostly quadratic function. Okay. So let's see this one. Can you see this graph? Okay, can you see this kind of graph? Okay, so this is decreasing. Why? Why it is decreasing? Because of the slope. Okay, the slope is decreasing. Alright, so how about this one? C and D. Okay, for C and D, there is a constant. Okay, there is a constant mendatang, maksudnya nilai C sama, nilai D pun sama. So how about from D to E? From D to E, okay, the slope is increasing. Okay, so how to determine it? Okay, it's just by looking the graph. Okay, the shapes of graph, we can determine whether it is increasing or decreasing. How to determine the nature of the function? So, to determine the nature of function, we have two methods. The first one is we use first derivative test. Okay, derivative test. And the second one is a second, derivative test. Okay, first derivative maksudnya You differentiate, okay, for one time. Okay, second derivative, okay, you differentiate, okay, twice times, okay? Alright, okay, we are not done yet here. So how about point E to F? Okay, obviously you can see that it is a decreasing. But actually we have a test to determine the nature of the function. Okay, so let's go further. Okay, increasing or decreasing. Okay, let's see the theorem. Let f be a continuous function on the interval AB. So bear in mind, for maximum and minimum form, it must be a function which is a continuous. Okay, apa maksud continuous? In chapter 1, okay, we already learned continuity. Continuous means that you can draw a graph, okay, without lifting a pen. Okay, you boleh draw macam ni. Okay, this is a continuous. Okay, continuous tanpa perlu, okay, you angkat pen you. That is a continuous function lah. Okay, so kalau you ada macam ni, so this is discontinuous. Okay, for this one, this is discontinuous. So kita tak boleh apply this theorem lah. Okay, kalau dia discontinuous, so we cannot apply this theorem. Okay, and even we cannot find the maximum and minimum point. Okay, so let's see the first theorem. If f prime is greater than 0 on the interval AB, interval AB ni adalah apa? Adalah point lah. Okay, kita panggil AB. Okay, A ni adalah point pada paksi X. B ni adalah point pada paksi Y. Okay, so then the function is increasing on the interval AB. Okay, kalau first derivative is greater than 0, okay, so the function is known as increasing. Okay, kalau f prime, okay, x greater than 0. So next, second theorem, if the first derivative is less than 0 on the interval AB, then the function is decreasing on the interval AB. So if the first derivative is less than 0, means that negative lah, you have a negative function. Okay, so the function is increasing. Apa yang increasing? The function lah. Okay, so this one is f prime x is less than 0. And the third theorem is if the first derivative is equal to 0 on the interval, okay, right? So what does it mean? Then the function, okay, is constant on AB, on the interval of AB. Okay, so let's see the next one, which is extrema point. Okay, in this subtopic, you will see we will use the terms relative extrema. Okay, so what is a relative extrema? Relative extrema of a function, okay, is occur only at the critical point or stationary point. So what is a critical point? Okay, critical point ni adalah pada C, okay, FC. So you kena cari dulu critical value. C ni apa? C ni adalah critical value and a critical point, okay, occur only at f prime x is equal to 0. Okay, critical value occur only at f prime x is equal to 0. Okay, so for relative extrema, okay, relative extrema, Okay, we have two types of relative extrema. So I write here relative extrema. Yeah? We have two types of relative extrema. Okay, they are, the first one is a relative maximum. And the second one is a relative minimum. Okay, so what is a relative maximum? So relative maximum, okay, of a function, okay, they are, okay, two types of finding the relative extremum lah. Okay, the first one that I said earlier in the previous slide is first derivative test, and the second method is by second derivative test. Okay, so before that, let's see another term that you have to know before we proceed to first derivative test. Okay, so it is very important for you to understand what is a critical value. Like I said earlier, critical value occur, okay, at f prime x is equal to 0. So here f prime, okay, x is equal to 0. Sorry. This one also. F prime is equal to 0. This one also. Okay. So if the function is a quadratic function or a function of a higher order, so there is a possibility of having more than one critical value. Okay, more than one critical value. So let's see types of graph. Yeah? A tangent line, which is a horizontal line, at x is equal to c, okay, which is f prime c is equal to 0. So this one is a tangent line for this function, okay, and for this one, this is a tangent line. Apa maksud tangent line? Tangent line adalah, okay, garis yang perpendicular dengan any point on the function. So kalau untuk maximum minimum ni, tangent line dia, okay, which is a perpendicular, okay, dengan point, okay. So here dekat sini lah, dia perpendicular kan. Perpendicular here, okay, sorry, dia tak straight. This one pun sama, tangent, okay, which is a tangent line, which is a perpendicular, okay, on a point of a function. Okay, so next, let's see the example. Okay, find the critical points of the curve fx is equal to 1/3x cubed minus 2x squared plus 3x plus 1. Okay, bear your mind that I said critical points only occur when, okay, f primes, okay, c is equal to 0. Okay, so let's differentiate this one. F prime X is equal to, okay, differentiate, okay, kalau you ada constant, silent constant 1 over 3, and then differentiate X cube, we got 3 X squared, right? So 2 turun depan, 2 times 2, 4 X plus 3 only. Okay, so nak tahu critical point? Critical point occur when F prime X is equal to 0, okay, at F prime X is equal to 0, so F prime X is equal to 1 over 3. Oh sorry, kita boleh cancel off here. Okay, sorry. Okay, dia akan jadi, here akan jadi X square sajalah yang tinggal. Minus 4x plus 3. So equal to 0. Why? Because of f prime x is equal to 0. F prime x is equal to 0. So what's next? Okay, you have to factorize because we want to find the critical points. Okay, critical points. Alright, so factorize this one. So x square, so kita bahagikan x. X, okay, 3 dengan 1 lah. Okay, so macam mana? Here. Okay, so you got X is equal to 3 and X is equal to 1. Okay, so next. We want to find a critical point. So critical point is, okay, so critical point kat sini you akan ada critical points lah sebab you ada 2 critical values. Okay, so critical point dia tak ada S lah because of general dia akan jadi C. So okay, ni lah you punya C and F prime C, critical point. Okay, so this one is your critical values. Okay, this one is a critical sebab ada 2 kan. So critical values, kalau you ada satu saja, so dia akan jadi critical value. Okay, singular. Okay, so next we want to find the critical point. Okay, so at x is equal to here. Ambil satu lah. Okay, start dengan yang smallest. So nak masuk dekat mana ni? Masuk kepada original function. Masuk kepada original function. So F, okay, 1 is equal to 1 over 3 times 1 cube minus 2, 1 square plus 3 times 1 plus 1. Okay, so you dapat apa? Ni 1 over 3 times 1 cube is 1 over 3 lah. So negative 2 plus 3, 1 plus 1 plus 2. Okay, so berapa? 3 times 2, 6 plus 1. So you got 7 over 3. So now we proceed with the next critical value which is x is equal to 3. So akan jadi F3 here. Substitute into the original function. Okay, 1 over 3. 3 cube minus 2 times. Okay. 3 square plus 3 times 3 plus 1. Okay, so 3 cubed, 27 over 3. Okay, minus 3 square, 9 times 2, 18. Plus 3 times 3, 9. Plus 1. Okay, so what's the answer? 27 divided by 3, you got 9. Minus 18 plus 9 plus 1. Okay, this one habis, so yang tinggal is 1. So therefore, what is the critical points of the curve? Therefore, the critical points are 1, okay, 7 over 3, and 3, 1. Okay, ni 1, 7 over 3, 3, and 1. Okay, so that is the answer. Okay, understand? Understand, class?